Gentlemen, welcome back to the shop. As the steward of your town pump CNC, I am reticent to alert you to the fact that there has been a change in the countenance. Now, the nose knows, but in this case, the ears hear something going on with the spindle. The tone has changed in the tool changer. Excuse me while I kiss this guy. We'll mic up the little dinkus end here. And then move that to where you can see her. Now, learning close and careful, real listenly. Well. Oh, now it's working. Sounds the same now. What the fuck, over? Just had to sit over the weekend. Which is what I convinced my wife to do. Now I could jump right to her hornier than a 10-peckered billy goat. That wouldn't get us any good because we don't know why the ka-chunk tonality changed. Was there some schmoo in there? Was there actually something? Is it just wearing in? It's the old chicken and the... I get into this with my wife all the time. Chicken and the egg. People get this wrong. So very wrong. The cock's got to lay the hen, then the hen lays the egg. So clearly it's the rooster what's got to come first. Previously, I was given a hot supper and the forcefulness of the docking just didn't seem up to the task. It didn't sound right. You can hear when something has changed, even though you can't identify it. So we'll get this thing hotted up. I just like to give her a couple drips of the drab. Oil's cheap. 1, 2. This is spindle lube. It does. I don't know. I'm not convinced it gets enough. I just like to give her a little extra. And then I'll run the warm-up routine and explain to you what we're going to do. Bleep, bloop, bloop. Anytime now. Wrong mode. Oh, for fuck. Too good for its own smart. There we go. Oh, the humanity. Despite having 6,000 years of mechanical fuckery under our belts, some guys still ain't hip to the prime directive. If it ain't broke, don't fix it. Of course, if and you want to be a cautionary tale, go ahead and rip everything apart and fix it till it is broke. I do not want to do that on this 20, 40, I don't know how much it's going to cost to rebuild a spindle. I just want to confirm without taking the thing apart. What we can do is have an instrument that will check the drawbar pressure. Now, I do not have said instrument. If you ain't got the tool to do the job, you got to make the tool what for doing the job. However, you can buy these about $1,000. For the 2 times per annum I'm going to use it, is that worth $1,000? No, I'm going to fabricable something together out of bits and bobs laying around here in the Empire dirt. And despite giving her a blast of the old strong opinion, as you can see, you never want to throw anything out. Got the dingus end right full of carbide. Can't blast her out, not for trying. Need a EDM machine. Yeah, it's coming. So is Christmas. So we're going to use this in order to make a hydraulic load cell. What it'll be, we'll nip that off. We'll nip this off. And then this is a proper turning job. However, I don't have a lathe here. And I also would have some trouble holding this taper true to the world. Instead of the lathe, we're going to use the mill. Now we got our apprentice-sized Cat 40 holder in the soft jaws, sacrificial soft jaws, on the parallels, saw cut, straight as a rainbow. So we're going to come in with the shell mill and just buck ourselves off around. I have a second kick at the cat here, the most important part of any YouTube machining operation. Of course, filming. Son of a diddling thing didn't record. Contact. Riveting, I know. The cinematic blur really adds to the effect. Square to the universe now is the first part of a 3-part instrument. We're going to have to bore this out to size, and then we'll put a pistone through here. In the pistone, we'll put a pressure gauge. Conveniently, pressure gauges come in pounds per square inch. So if we can make this effective area 1 square inch, then we can just read directly off the gauge. Now, the beauty of this is, I'm not quite sure it's going to work. But that is what makes it worth trying. I don't know. So I was going to pick up this center bore because I want to do all the ops from this one. You know, when you move your workpiece around and you're doing long bores, you're going to screw yourself up. At least I learned that much. Now we are going to, let me hit this. We're going to use the Haas visual programming system to try and do these bores. Pain right in the cunning linguals. If it is, we'll go to the confuser, make a model, and yada yada yada. But yeah, I always get bit in the ass by shortcuts, and yet I still take them. You can see we're probed in, dead nuts right in the center of that bore, so we're happy. We're gonna go with 20143. That's a 1/2 inch drill bit in a collet. 81, that's a long hole. That's just a standard plunge it down. We want to go 83, and that'll give us a little peck action. Speed, about that many. Looks okay to me. Here we go. Oh, Jesus. Let's turn that rapid down a little bit. Yeah, we're good. Nice and slow feed. The thing is, it's not optimized for production. We're only running but one hole, so what the point is to melt a drill bit? Just that first entry sounded kind of nasty, but we're good there now. Oh, we got a vibration. Okay, I'm gonna calm that down a little bit by reducing the feed rate to 70%. And we'll also reduce the spindle a little bit. See how that goes. Oh, terrible. Let's go up on the spindle. No. Wow, what the fuck, over? Who'd have thunk drilling a hole would be so complicated? How many times I gotta make the same mistake over and over? Apparently over and over. Too lazy to look up the table and melted the tip right off of it. Lucky I didn't get stuck in the hole. That would have put a fuck right in my whole week. So, yeah. The true measure of a master is not breaking the tool, but getting the broken tool in the bucket before anybody notices. Forgot, even though this is soft, it's still tough as woodpecker lips because it's tool steel, so I had the settings about double what they ought to be. I'm gonna go in here and peck down 3/8 of an inch and hopefully don't bust a drill bit. If and we get past this hard spot, she's pretty gnarly, then smooth sailing from here on in. Otherwise we got to go in there with some carbide and yeah, that ain't gonna work. I gotta get in there with some carbide. We're gonna go T80, which is a stub rougher 1/2 inch. This next part's gonna be a little bit boring. Just bear with me through the schmoo. Anytime now. .5/8, that's .625 long dong rougher in there. You can see how far the dingus end dangles out. And we're not T-bag. We got it roughed in there on the bore using that visual programming system, which is conversational. Well, pleasantly surprised. This bore routine, it actually works half decent. The only thing you got to watch is the final pass does full depth. So you saw how far that was, 2 1/4 depth of cut. It did the full pass at, it did the full depth of cut at that finishing pass. So a little sketchy, but in order to finish bore that cylinder, we're gonna use a 3-carter, 5 flute end mill titanium, aluminum nitride coated, vapor deposited. The thing is, they don't tell you here, there's quite a bit of art to this science. This is a test run of the finish pass. Bit of a problem, unforeseen difficulty. Of course, if it was foreseen, it wouldn't be a difficulty. The polar or linear interpolation. The confuser only runs at 90-degree axes, so it has to interpolate circular moves. You can see each one of these little marks, what looks like chowder marks. I assure you that 3-carter inch end mill and the fixturing, no chatter at all in her. What's happening is we're seeing the confuser marks. The only way to get rid of them is to model this in Fusion and then go and change the fineness. Lucky for us, O-rings hide a multitude of sins. There's a two-fluted metric abomination. Boring in real slow. Well, you can't see fuck all anyway. 3 inches per minute. Taking tiny bites. Pearls of wisdom just dropping out of the sky. Only trouble is getting hit and killed. The two-flute Chinesium insert end mill does not a boring head make. Terrible finish. Just atrocious. So the only end mill I got what'll cut that depth is a 3-flute made for aluminium. This is tool steel. I'm gonna try it. We're gonna go nice and slow and just take a skim cut, try and polish up that bore. It's chowdered up proper now, so I actually gotta oversize it a little bit. That performs stupendously. Razor sharp edges aside, that bore is beautiful. We'll leave the hand finishing till the very last when we got all the parts, but there's the cylinder body / Cat 40 holder done. I don't have any 4041 shafting, which would be ideal for this, but I do have some 01 oil hardening. It's annealed, should be soft enough and easy enough to machine, strong enough to use. So what I need to do now is grip this in the vise. In order to do that, we got to have some soft jaws with round bits. I got that 01 hung up pretty good, but I bored out the jaws, touching in 4 spots of contact, and cinched her right up. Seems to be doing okay. We're just cleaning up that edge. We'll flip her around, clean up the other edge, and then we'll do some actual work. There's a 1/2 inch 4-flute rougher. Got her running at but 5 inches per minute, nice and slow. 0.625 depth of cut and 100th thou step over. No chatter at all, nice and solid. Again, onesies and twosies. We're not looking for production. We're not looking for taking the biggest chip. We just want to get through it without breaking anything. Yeah, we're almost there. Another thou and a half. I'll give her 2 thou. I got a good feeling about that. That's 2 thou on the diameter, mind, so that's only a thou depth of cut. Oh. Beauty. The piston fitment is good. It is reversed. It's backwards just to check it. And then I went ahead and milled it flat, came in with a spotting drill and then T-drilled so that we can get oil from the pressure gallery to the gauge. Now what we got to do is mill the rod end. At the 1/2 inch drill bit, a new one. We're going to do better this time. 450 Ripwams, 1.3 feed. Pretty critical, that feed. And we're going to whop the coolant to her. The first part of the hole is always gnarly sounding. It's just the flutes trying to find where they're going. Okay, fuck me, we're stopping that. Drilling, bane of my bloody existence. Wiped out the tip, just the tip, instantanément. Yeah, look at that. Both flutes just instantly dickered. Well, we're getting there. First hole we drilled, melted the drill bit. Second hole we drilled, well, it just got the flutes. So we're dialing her back. Speed 425 and the feed 0.8. Seems way happier. Welcome to the world, little buddy. Tool steel, it ain't no picnic. They're using the mill to get reasonably accurate enough for O-ring sealing. Not teabag, but this is just fucking stupid. The length of her, you never get an end mill that'll do 2.5 inches depth of cut. Remember, everything is a spring, so it kicks out, and you gotta. This is just fucking stupid, banging my head against the wall. I'm gonna take this home, run her in the lathe. Clock that. Like that. Taper off. So yeah, machined this in the usual way, forward jaw indicated, and then made sure it wasn't cut and tapered because of the tailstock being cocked over, and then just put in these quad rings, a little grease, Bob's your auntie. So the problem is, of course, here's the big problem, which I figured I was so chuffed, patting myself on the back that I don't know. You keep making the same mistakes over and over and over. It's like I'm human or something. So this has an effective area of 1 inch, but I neglected to consider that the rod, you have to subtract the rod diameter from that effective area. So what is happening here is we have just this little sliver of land here giving us the effective area. That means that the pressure going to be through the roof. Now, no big deal. I have high pressure gauges. However, you put 10,000 pissies in here on this little ring, she's apt to smoke out a little bit. So it, you know, I don't know how much a spindle is going to cost me in that CNC Haas power machine, but I don't really want to find out either. We're just about ready to try this out. Of course, I don't have a Cat 40 spindle here, but we can. I calculated the rod against the piston. We're left with an effective area around there of 0.45, so half a square inch. That means if the drawbar pulls 2,000 pounds, we're going to see 4,000, well, at half, we'd see 4,000, but we'll see somewhere around 4,500 PSI. And we'll pack that full of non-compressible fluid. I told you this before, and I'll tell you again, Mama didn't raise no fool. That's the beauty of grease. Not only is it incompressible, virtually incompressible at these pressures, but it's also nice and thick, self-sealing, you might say. Yeah, it already wants to seal, see? Aha! And then we'll just force that down in there if we can. Alright, engage your safety squints. We're going to give her a little bit of pressure here. There's a cold breeze in your eye. Coming up nice, no blowouts. Probably shouldn't have my hand near this. I think we're good. The day is well past the morrow. Spidey sense of tingling. I ain't sure if this is going to work. Of course, you're only sure if it's going to work because you already done it before. What's the fun in that? I tell you, none at all. So while this thing warms up, we're going to have a set and a proper dead wrecking sesh. There's a little game I like to play with myself. It's not my favorite game, mine, but this is a family channel. What is going to kill us next? If it's one thing I learned about that Jesus CNC, you do not hit the go green button unless you're 100% certain it's going to work. Nothing is going to fuck up. So that still leaves the unforeseen, what you don't think about what's going to fuck up. So what we are doing here is dispelling the fog of war as much as we can, relying on our heuristics and our training to eliminate what is going to kill us next. That's the name of the game. We're dealing with very high pressures. So we could blow out a seal. We could inject ourselves with shmoo. So that means keep your hands away. We're also laboring under an assumption that the drawbar pull is 2,000 pounds. I don't know. So I'm going to go on the confuser, look up the spec. It's actually lower than I suspected, 1,400 to 2,000 on this. Sorry about the, yeah. Tough to get good gaffers these days. The wireless mic there, dingle dangling in your face. It was like religion. You know, that's fantastic. You got it. I don't want you flopping it in my face. So apologize for that. So 2,000, we'll say 14, well, we'll leave it at 2,000. I think the range is ridiculous. It goes from 1,400 to 2,000. So that's a pretty wide berth. Okay, so if we have 2,000 pounds of drawbar pull, given the effective area of 0.55 inches, we're going to get 44 pity a dick, 44444 PSI. That's what we're expecting to see. Now, are these seals going to handle it? Probably. If not, what's the worst that happens? we blow out a seal, some schmoo leaks out, nobody gets hurt. What else is going to kill us? Well, now we have the pressure contained herein, and remember, everything is a spring. So I'm worried about this expanding and ruining the spindle, but it's in the bottom half. The piston area and the cylinder is in the bottom half. A fair bit of meat there. We get 44. This is probably 60 KSI steel, probably 80. Responsibly 80 KSI steel. How much is that going to expand with a 1.126 inch bore? Not very. Now, the interface of the spindle, we got to make sure that we don't caulk it over with a sharp edge. So I've broken that and sanded it. Not just chamfered. Of course, when you chamfer something at 45, you still get two knife edges, top and bottom. I've sanded this and rounded it, so we're good there. Now, because we've taken a lot of meat out here, is there too much pressure on this little area? Well, you look at that now. That's through the planar centroid of the area, 1/3 down here. We're getting about 1.5 inches diameter. So 3.14 pi times 1.5 inches, the 4 3/4 times that. And we never go all the way in. So that's about 1 inch. So we got an effective area here of 475 square inches, 2,000 pounds divided by 475. Fuck all in a big ship. 500 pounds per square inch of pressure on that spindle bore. What else is going to kill us? After a modicum of consideration, I do believe we're going to be okay. I'll cycle that drawbar a couple times with the tool. However, if you got any objections, go ahead and go back to the future. Let me know ahead of time. I'd appreciate it. And we ought to run that spindle, warm that spindle up a little bit, just to get the bearings lubricated and so forth. This here machine don't give a fuck about my false bravado, so let's not do this right over the penis shield. Maybe move her over a little. Hand jog would help. Or anything more noble, more embiggening of the smallest stature, and venturing boldly into the unknown. And okay, quit your jabberwocking. Oh fuck. Oh fuck. Oh fuck. Ha! Reading the gauge, we're at 30, just a blonde one shy of 33. Good enough for the girls I go out with. We're having some stiction issues with this O-ring. Ginger carefully with the pick. You don't want schmoo in your face. This thing's like a loaded weapon. You see we're bulging out here, but because we had the quad ring, it's got two sealing nodes and it's sealing on the bottom. And we can see that I filled that good and proper with grease because there's not that much compression. It didn't pull in all that much. So we're getting some stiction here. 3,300 times 0.45, we're right around 1,500 pounds of pull. Maybe 1475, between 1,500 and 1475. So pretty fucking good. Pretty fucking good for a scabby instrument like this. I'm gonna have a go at this O-ring again, see if I can't get her to plug in. If I cycle this a few times, it'll probably maybe work some, no, well it's deadheaded, so it won't work the air out, but might work the O-ring out. Now hopefully I solved one of the problems. I took a quarter thimbleful of grease out of her. At a couple milliliters in metric. So now the O-ring sits further in there, so we shouldn't have that much stiction from it. Beauty, beauty, beauty. So we're at 45, just a blonde one shy of 45 hundy. That gives us 2,000 pounds of drawbar pull. So we were getting quite a bit of stiction out of that seal. A very specialized high force load cell. There you have it, well within the capabilities of a dude with a lathe, essentially. And you see that seals, hydraulic seals, not that big a deal, especially when you're dealing with static sealing. And you can cheat, you put a little grease in there and she seals up nice. Now, one thing we got to do, of course, is prevent this from popping out, so I'll have to put a circlip in the next iteration. And I want that bore to be dead nuts on effective area of 1 inch so that we can read the gauge off directly rather than doing some mental mathematics. Yeah, you see, it pops that out first. That ain't no fucking good, because you got to reseat it every time you use it. However, how many times are you going to use it? So thanks for watching. Keep your dick in a vise.